Hello and welcome to the world of advanced analytical technology with Elvatech's handheld analyzer, which are widely used in the analysis of metals and alloys, ores, soils, and many other materials. Today, we'll introduce you to the averaging mode feature that makes ProSpector 3 the indispensable tool across various industrial sectors. During analysis of different materials, the researcher is not protected from random errors. They can be caused by anything from changes in environmental conditions such as temperature, humidity, vibrations, electromagnetic fields, to the usual subjective errors of the researcher. Averaging measurement results minimizes the influence of random factors and provides more accurate results. In practice, this means that each object is analyzed several times, and then the average value of the measurement is calculated, which reduces the impact of possible errors. There are materials for which the averaging value of the test result is mandatory, since without it, the information obtained during laboratory analysis is distorted. Precious metals alloys, soils, geological samples, ores, rare earth elements, clay, ceramics, and liquids and powders are heterogeneous by their nature, which requires precise analysis to determine their composition. When we use an XRF analyzer to examine a homogeneous samples, it is important to understand that the X-rays are impacting the specific point of the object. This allows you to obtain detailed information about the composition and properties of the point. If the material structure of our sample is not homogeneous, changes in its position during the analysis can affect the result. This means that we can get different data for same sample if we examine it in different spots. That's why the use of the method of averaging results is critical when working with heterogeneous materials. It allows us to obtain a more accurate and complete analysis, ensuring the reliability and accuracy of our results. Elvatech's XRF spectrometers, both portable and benchtop, have a built-in averaging function to help you save time during measurements analysis. Now we will show you how it works, so let's turn the device. First of all, before we start with any measurements on averaging, we need to determine which exact calibration we're gonna use and the averaging mode of this calibration. So now we have some of the mining samples, it's ores, so we need to go to the mining mode and here just select the averaging and let's put it just 3 measurements. So after we set in the 3 measurements, it basically means that we need to find each spot for each measurement, and each of them should be different. This is the way how we can make the averaging analysis from just one sample. So after we're done with the first measurement, we just need to locate the point, the spot where we take a measurement. So I have just a brief thing here, so it makes me understand that I shouldn't measure on this side. Let's just turn it off. And now when it's upside down, let's take a measurement of this part. And always remember, you should keep your hands out of the sample that you are measuring. So as we're done with the all 3 analysis, you will see the averaging screen. It appears actually on your touch screen, the averaging mode, and you can scroll to all 3 analysis here. As you can see, the name of analysis is on the top right corner. Now it says 1. And let's just briefly look through all the data from the first one. And now let's go to the second one. So just to compare, let's say top 3, the silicon, aluminum, and gallium, we have here pretty similar data. It differs for sure, but it's ore, you should know it. But the third one is like absolutely different. Let's say this way. It was done when we had the rock upside down, and it was done from the different side. As you remember, we had the first one here, the second one was here, and the third part, it was upside down. So now you can see how is important the averaging mode for analysis of not homogeneous samples, especially when it's in a solid condition. This was an example for a solid sample. Similarly, you can test other materials, such as powders and liquids, in the same way, but using the lab stand. For powder samples, after each measurement, they should be mixed or shaken, so the every next analysis helps to obtain more information about the investigating material. To apply the averaging method in real life, let's look at the simple example. Let's imagine that you are working in a foundry and you value mobility, speed, convenience, and accessibility to your work. In this case, the ProSpector 3 handheld XRF analyzer is the perfect tool for checking samples right in the production workplace. This analyzer provides fast results, doesn't damage the material during the analysis, allows you to perform non-stop testing in the field, does not require professional training for operation, as it is user-friendly interface and can be easily converted into a benchtop spectrometer using a lab stand, and can connect with other devices to transfer and process the results. Experienced professionals in the metal production industry know that achieving the perfect manufacturing process requires detailed checks and numerous experiments for each production batch. Exactly in such cases, the built-in method of averaging the result will help you to see the inaccuracy that occurred during the manufacture of the material and identify the problem area of the investigated product. If you have any questions or are interested in our spectrometers, you can contact our managers by the phone or email. We are always ready to answer your questions and unlock for you a world of accurate, high quality, and modern analysis with our XRF spectrometers that will help you to increase productivity, save money, and save your time. Don't miss out our next reviews and interesting video. Subscribe to our YouTube channel. Just click the subscribe button and don't forget to click the bell to receive notifications of new videos. Also, don't forget to like this video so we know you enjoy it. Stay tuned and see you soon.